Okay, hello everyone. My name is Petr Šmejkal and I come from the company Outreach. Outreach makes a service that helps seller people to sell better, faster, more effective. We have a development center in Prague. There are almost 100 people, mostly engineering, some technical support and other areas. We are hiring, that's what we do. And something about me and why I'm here. So when I started working, I was analyst, programmer, consultant, engineering manager. That's what I'm now. I worked with various databases, but I was always data oriented. So there are people that start with programming. They look at things from the programming point of view. Whenever I came to a new project, I always wanted to know like how the tables are organized, what are the relationships, and I always looked like from the data point of view. In Outreach, I lead a team that's called now Administration Developer Services. You can imagine anything that our partners and customers can use to connect their servers with ours. So we have a lot of things like public API, OAuth authentication, and several backend services that support the whole platform. When I started, I don't know, 20-ish years ago, this was my first contact with the real databases. In the beginning, I was writing simple code that reads text files, and there was a little bit of structure there as well. But this was my first touch of the real world databases, and I liked it a lot. Like all the nasty stuff was abstracted, and I love ACID, who doesn't, right? And do you know what programming language is that? No? Thank you, Perl, yes. I love that language. I used it a lot in the past. Now, not so much, but I still like it. What I like the most is that I didn't really have to think about the way how I connect to the database and how I fetch the data about any type conversions and everything. It was like very neatly connected together. I could decide on spot whether I want the result in a hash map or in array, or like use binding variables, whether I want to fetch just single row or not. And it was nice. But I also wanted to be a good programmer. And programmers think slightly differently than database people. I learned that there is a thing called ORM. Question: do you use ORMs? Raise your hands, please. Thank you. I learned that ORMs are somewhat different than like my way of thinking is making me work. So what the ORM is actually. If you start a program, you start like modeling entities and relationships for your code, for your program, and then at certain point you realize it's nice to have persistence, like store data, be able to retrieve them, and so on. So you look for solutions that make your life easier or are supposed to make your life easier, and you resort to one of the libraries that your programming language supports, and it forces you to work in a certain way. So it helps you to get rid of the like complexities in type conversions and writing a lot of boilerplate, and it forces a certain style that's in some ways beneficial, but it comes with a price. I have seen several ORMs, and it wasn't always like the nice experience. The easy solutions, which like most people are looking for, are not that performant, not that good. And good ORMs are super complex. And you need to learn a lot, and you need to know how to work with them properly, and so on. So you might ask what I disliked. When I came to Outreach, my first project was about extensibility applications and creating something like a dev portal where other people can publish their extensions to Outreach. This is not exactly ERD, but it shows like the complex relationships that we have between tables and records and so on. And it was built on top of End, Go language ORM. And immediately when I came, I disliked how it's built, how it works, how the naming is like super complicated, and especially when you are used to use PSQL and write queries, it really pisses you a lot if you need to write marketplace application ID every time. And yeah. It might not be that complicated, but the ORM forced certain ways how records are linked, and it might be done differently. It might be done in a slightly more optimized way. So what I disliked, it reads too much. Sometimes you need just like few attributes for that particular endpoint or use case, but ORM typically reads the whole record. And if you have several big blobs there, it's difficult to avoid it. There are ORMs that have function like plug for Ruby on Rails that reads just like the really small portion of it, but not every ORM has it. What surprised me the most is how inefficient the queries are. Normally, when you are responsible for writing the query, you can use a lot of database functionality that is available to you, but ORMs make it simple. So they query one table, get all the attributes, including the IDs of foreign objects. Then they send to the server another query with the list of IDs reading the related records. Some just cannot make it into one join and one query. What was a nightmare was like scattered conditions. So when you are using ORM, you have various nice functions how to compose the list of where conditions. And it allows you to scatter all these functions to various modules in your application code. And it seems that it's a good idea to have, I don't know, authentication related stuff in one module, then like something for filtering in another, then conditions for cursors somewhere else. And then like you magically stitch it and it works. But when you are trying to debug it and actually see what is sent to database and whether it like makes sense or not, it's very, very difficult. I have seen ORMs that try to be like very universal, and they use reflection a lot. They look like into which type object are you trying to store the data. They like touch everything and then prepare code that converts the values from here to there. And they do it every time you execute the query. So it's super inefficient. As a database guy, I really liked all the new features that came with every new version of Postgres, and I'm quite old, so I like enjoyed a lot of Christmas gifts from the Postgres community, and I realized that I'm not able to use them actually because it's not me who writes the SQL query. It's like some code that has no idea this is possible and does it in other way, and yeah, I was suffering a bit. And using ORM means that a lot of logic needs to be written in the application code. Many people consider it actually a benefit, but we all know that like there needs to be a balance in separating the logic in database and application. And if you are forced or pushed in one direction only, it's never good. So are there some benefits? Yes, I have to admit. So ORMs in many cases come with some way how the database schema and object model is managed. So you use the capabilities of the ORM to prepare migration scripts and deploy them somehow separately from the application code. And in many cases, it like forces good habits. Obviously, it saves some of your time by nicely bridging like what's your application model and database model. And yeah, in certain cases, it makes your life easier. And it's really great if you need to write dynamic queries. So imagine a simple list view in UI. User has ability to filter by 13 attributes that are there, order ascending, descending order by like all the 20 columns that are returned. And well, you need some nice way how to convert whatever user entered in the UI into a SQL query, and ORMs really help with that. But back to my outreach experience. I wasn't alone who is feeling like very negative about the way how the system was originally built and what architecture decisions were made. And we felt that it's stopping us from implementing more features and doing it faster or in more effective way. We asked around in the company like what people are using, whether there is a better ORM or like different way. Obviously, we wanted to avoid the direct approach, like using PGX and writing scans, and there would be like a lot of boilerplate that we would need to write, and as many of you, we are lazy. So fortunately, I was the manager, and I could decide that we can invest into rewriting the whole application and getting rid of the end ORM, replace it with something else. The problem was like what to use. Like, should we pick some other ORM that does it better? We did an investigation, didn't find really anything, and then someone told me that there is sqlc. It kind of reminded me of one funny situation. One of my colleagues asked in the group if we could recommend some restaurant with running sushi. And the answer was, well, have you tried it like separate, running and sushi? You will enjoy it much more. And this is very similar. So sqlc allows you to have the SQL code separate from your application code, and it provides the bridge in between. What you see on the screen is copy-paste from their documentation site, and might sound like a marketing stuff, but it really describes well what is it about. So you write your SQL queries in one file, annotate them, name them. It generates a code that allows to call these queries. It nicely prepares all the inputs and outputs, and you have like specialized functions for each of the query written. I had a demo prepared, but yesterday I realized that this playground is out of service. So I'll sit for a moment and show it to you in a different way. So with sqlc, you start with a simple configuration that you can copy paste from their site. It allows you to slightly modify the code that's generated. Then, obviously, you need to feed it with the database schema. sqlc doesn't force you to use a particular way how you manage the schema. You can send it to a folder where you have all the migration files that create or alter tables. There can be multiple files ordered and it just reads them. You can just dump your schema without data into a file and send sqlc there. There might be some other ways. It supports like various other migration frameworks, so it's relatively flexible. Then you have a file with all the select, update, delete, insert statements that you use in your application. At the first sight, it looked weird that like you need to cut them out of your code and place them somewhere else. But once you get used to it, it's actually it's nice. Like you see all the statements, you can get inspiration from it. You don't need to look for these magical strings that are actually not, or that are usually scattered like in several places. And you neatly see it in like one file. You can have multiple files if you want. You can logically separate them into different modules or files. And one of the like founding principle is that you don't use anything special besides the name and the actual query that looks exactly like what is sent to the database, almost. So what sqlc does for you when you, oh, this was supposed to be bigger. Yeah. If you run it with the generate parameter, it looks at your schema, it looks at your SQL files, and generates a Go code. It supports several languages, Kotlin, JavaScript, Python, maybe something else. There's like 5, 6 of them. As we are using Go, I'm showing you Go code. And every query is copy-pasted into a constant, and there are structures, if necessary, prepared for the input and output, and there is a function created or method created for each of the queries that executes it. It comes with a simple interface, which I don't see now. Why? Oh, here it is. So if you want to instantiate it, you just pass the connection handler to it that implements these 4 functions, and that's it. So it can be used with any database library that comes with Go and supports this or implements this interface. We use sometimes the standard SQL, sometimes PGX. It works with both. And there is really no problem with like plugging it into your application, and you get this query structure with all these methods that represent your queries. So that was the first part of the demo. I talked about the inputs, outputs, and we can continue with nice features that it has. So you might notice that you need to name each query. Naming is difficult, yes, but it's still easy compared to other things. You need to say whether this function that wraps the query should return one row, many rows, or nothing, or just like a result and number of rows affected if you need. It expands the asterisk for you. So if you select star from a table, it prepares a structure that contains all named rows, all named columns from the table, and it gives you like a really nicely usable result. There is inbuilt nullable type detection. So from the schema, it knows whether that particular attribute of the table is nullable or not, and returns nullable wrapper of the type, or returns pointer to the type if you configure it so. It even recognizes left joins and prepares everything for you. As I said, it's compatible with various drivers and various type conversions that come with the driver, and it recognizes everything nicely. What's really awesome is that you have compile time verification of all the queries. So if you make a typo, if you write something that doesn't make sense or there is like syntax error in the query, it tells you before you actually run tests, it tells you during the compilation. And as I said, it supports a lot of languages, and it also supports several other databases, not just Postgres. So let's look at whether it meets what, yes? Yes. No, that's a good question. Yes, it uses pieces of code from Postgres to parse the schema and all the queries. So it doesn't need a running database to do anything. It just does everything itself, and it's somehow linked with the Postgres library, so it really uses the same parser. The same, like it contains parser that's almost identical with what other databases use, so it understands all the types, relationships, and so on in your queries and schema, and generates the code for the programming language of your choice. I'll show you in one more demo, so we can look at the errors it reports if you mistype something, and how it works in detail. Okay, this is nice, and není. Maybe I'll come closer to you. Jo. Yeah. So schema maintenance, there is none in sqlc, as I said. So you need to use some other ways. And for Go, we have Golang migrate library. It's proven to work. It's worked nicely. We can use it. You can use anything else. Bridging your objects in memory representation with database structures. That's why we use it. You don't really like load it into some nice object model, but that's not always wanted. You need to have like nice, fully type-safe representation of the data. That's what you get, but you don't need to have everything in the object model. Unfortunately, there is one thing that's not really solved, and that's the dynamic SQL generation that you would appreciate when you need to support like user filters and so on. So when I saw the sqlc for the first time, I fell in love. I really liked the way how it separates the SQL and Go code and how it works, what it does. The examples and documentations are really well written, so you immediately understand how to work with it. And once you start working with it, you realize that it has limits. It's not like generally usable for everything, but it excels in certain things, and that's like why we chose it and why we started using it. The nullable type detection works well. It knows what's in the database, but it doesn't know what you want. So sometimes you have a nullable column that you somehow that needs to be nullable in the database, but for that particular use case in your insert query, you need you always pass some value. So it doesn't make sense to wrap it with the nullable wrapper around the type or pass it as a pointer or something like that. So it's sometimes hard to persuade it to not use nullable types. As you might have seen, it creates a structure for every input and output of every query. So suddenly you have like a lot of structures, and some of them have absolutely the same content. If you return the same columns from several queries, it would be nice to like use one and share it, but it's not doing it like out of the box. As I said in the beginning, you can write select star and it like gives you nicely the resolved list of columns, but it complicates the column removal. If you want to remove a column, you alter table drop column, that usually gets deployed sooner. And you have to have it in the migration files to let sqlc know that you are going to drop it to generate the code without it. But as the migrations get deployed sooner than your application code, for some brief moment, you might be in a situation that the old version of the application queries the column that's already not there. And the simple solution is simply not to use select star. That's all. Like if you avoid that and always name all your columns, you always get like a consistent version of your application or backwards compatible version of the application. And we still have the problem with list view queries. So filtering, it is really complicated. So fixing nullable types. I resorted back to my favorite language, Perl, and wrote a simple parser that post-processes the Go-generated file. I never used code generation before Go, actually, and at the first attempt, it looked weird that you are generating your code based on something else and then modifying it by another script, and it can chain. But Go has nice way of making it happen, wrapping it, and it's built around it. Like it's used a lot, so not problem with that. In this example, you simply pick the types and attributes and replace the original type with something else, and that's it. Reusing structures across queries, that was a different beast. So I wrote another Perl parser that looks at the generated file. It gets the content of every structure generated by sqlc, compares all of them to see whether there are some matches, and it suggests you to merge this to that. So then the inputs or outputs from those functions uses the same type. You can easily share it in your application code, and it comes with a lot of benefits. The Perl code for that is slightly more complicated. I'm not going to show you the code, but I'm going to show you how it works. And it allows you to specify the input type as another annotation in your query. So if you have two queries that return the same columns, you can easily use the same type. Okay, so we can get back to demos, and I'll show you more how it works. So I have another file with SQL queries. One is insert, one is select. It doesn't matter. The insert returns some rows that were inserted. And because it's similar to what the first query returns, I wanted to use one common type. So my magical Perl script, when it gets executed, goes through the generated file, and or you know what? I'll do it differently. I'll just show you the differences. So this is without the post-processing, and as you can see, there are two structures generated with or named after the query name. And you cannot really do much with that. If you do the post-processing changes, one of the structure disappeared from here, and the create function is actually referencing the list authors structure that comes with the other query. And I can show you more. I can show you how things change when you make a typo. So let's say that I remove the age from authors. There is obviously no such table in the schema. And when I run the code generation, it says sorry. So immediately you see errors. It doesn't catch everything. It doesn't understand functions, for example. So it's fine with all the custom functions that you use. But many of these typos and bugs are caught during the compilation time. Yeah, so you can use various ways how to name parameters on input. If you start with simple 1, 2, 3, like a placeholders for binding the variables, it knows that you are going to insert name, bio, and bday into the table. So in the generated input parameters, it automatically names them correctly. It doesn't use like column 1, column 2, column 3, but it derives the name from the schema. As you can see, this bio and bday are nullable, and you might not want that. So there are various ways how to fix that. So if you use named parameter instead of this like to reference a particular column, you need to help sqlc with defining the proper type, and then when we execute it, of course. Okay. So now when we execute it, we see that the bio is string and not nullable string. Other way around is that we use my script, but it doesn't work for output, or like these hacks do not work for output. So for that we would need to use the post-processing script. It's relatively easy to make the attribute nullable if you need. They have like special syntax for that. And I think that's enough for this part. We can go to next slide. So list views. There are several ways how to circumvent the limitations. You can write super ugly queries that will certainly please your planner. And you can say something like this, that like if one parameter is true or false, consider this condition valid or not. Or if the value is null, or be happy with it. If it's not, make sure that you use it as a filter. This is like a way to go. Yes, it works, but you will certainly have problem with slow queries, not using the right indexes, and so on. It's even more complicated when you need to order the result in a certain way. So yes, there is a way how to do that. It works, but it's super inefficient. I needed to find a way how to fix that. And as I said, one of the foundation principles of sqlc is that you don't need to use any kind of macros, any kind of like a extra language layer between the SQL and your code. I decided that it's time to break this rule and use some like a special syntax that will be interpreted by the generated code, and it will allow what I need to do. So you remember the syntax, right? That if the variable has a value, use it. That's exactly what's here. So isValue is not a function that I would have in my Postgres, and definitely I'm not going to evaluate it as like being in certain list or array. But it's a special macro that sqlc accepts because it's valid syntax. And if it recognizes it correctly, it generates slightly different code, pre-processing the query and generating the right query based on the input parameters. So it exactly says what you write here. If there is a value in filter B, make sure that the column B equals the filter B. The same for C. You call it with a structure that contains filter B, filter C, and if you call it like this, that the B is empty string and C has a value, it converts it into this query that actually goes to database. So the planner knows that you are using just one column filtering. It can use the index correctly, and it's super efficient. How it is done? So this is the query without the post-processing script executed. If I execute it, yes. So it uses some regexes to parse the input, and it pre-caches some of the values found in the query to recognize types properly, to generate the right code for each attribute to figure out whether it's empty or not. And then the listBooks function gets the first static portion of the query, and it checks whether the argument representing author's name is empty or not. And if it's not, then it adds the tiny little portion that was in the brackets that represents the filtering condition for author name. So, sorry, if I look back, it practically removes this part and keeps just whatever is in here and passes that further. It does that for every known attribute. It recognizes correctly, like strings, booleans, numbers, and timestamps, and formats the query. There are few little troubles. Yeah, so you can use named parameters or position parameters here, and you kind of cannot skip some, or like you need to use all of them that are then on the input. And for that, we use a trick. Fortunately, Postgres ignores every constant that's in the order by clause. So we just like edit after whatever we need in the order by as constants. And we make Postgres happy and make the query executable with the constant array of or structure of params that comes on the input. There is a similar way how to solve the problem with sorting and paging. There is a special function called cursor for. You pass it some constant. It creates an enum out of or cursor for occurrences in the query that's appended to your input. And you place all the filtering conditions in brackets. Use special sort key that's somehow generated, or this order by is replaced with a portion of code that is generated from the query, and yes, limit is easily understandable. I don't have an example for that, but this is how you use it. And I have a small bonus for you. Usually, if you use migration files, you need to use statements like create or replace for functions or triggers. And in pull request, it's very difficult to understand what actually changed, because you have the version in one file, and then you have like named or numbered file that follows, and you don't see the differences. I wrote a simple bash script that takes the pSQL output, converts it into Markdown. You just fix the pSQL version not to get updated with every major update, or even sometimes minor, and you use set or parallel to slightly modify the output, and you can get nice Markdown files like this, including the function body. And if you put it into your Go generate list of things that are executed when you compile the code, or if you make it part of the CI pipeline, you can see the differences of the previous and the new version of every function in the documentation. So it really helps with making or ensuring that everything's fine. And this is the last slide. So sqlc, in my eyes, is awesome. It's not a universal solution. It really helps you with static queries. It's slightly more difficult to be used with dynamic queries. We are still using it in many projects. It didn't. We didn't finish with one microservice, but now it's like in 5 that are developed by my team. And in one of these services, we have like flexible schema. We allow customers to define their own objects, and that's something that sqlc cannot be used. So we resorted to really formatting the query using a string builder and custom conditions and so on. But I would say it's an edge case. Otherwise, I would definitely recommend using it. So thank you for your attention. And if you have any queries, if you have any questions, it's time for you to ask. When I was trying to figure out how to circumvent the limitations of pure sqlc, I found a lot of discussions online in the sqlc GitHub, and people are like super opinionated. They really want to keep the sqlc very lean and not introduce any additional syntax or like allow you to write the SQL queries exactly as are passed to database. That's the foundational rule of like why it was made this way. I wouldn't do things differently, to be honest. We are not looking for anything else to replace it. We are fine with all these like extra post-processings. Yes, we spent some time writing it, but now with AI, it should be super simple to write a parser, and like I definitely recommend this way. I didn't even try to propose some changes to sqlc because I have read all these opinionated discussions, and I thought that like such change wouldn't be welcome. So we resorted to our custom solution, and it really works great for us.
Okay, so then, thank you.